Morning, ladies and gents. Today, what we're going to be doing is we're going to be exploring those ideas of relative masses with zinc and hydrochloric acid. So, very first thing that we need to realize is that when we are reacting zinc and hydrochloric acid together, there are a load of different possibilities which it could actually, create. So, if you think about zinc as just like something A, like a building block A, and H from the hydrochloric acid is like a building block B, and chlorine as building block C, what are the different combinations that you could have of A, B, and C together? And there's, we think there's 4. So what I want you to do is I want you to pause the video, write down those 4 combinations, and then come back and see if we get the same ones. So, pause the video. All right, welcome back. So, did you get all of them together? They would have zinc, hydrochloric, or H and Cl all together. Did you get zinc with the hydrogen and then Cl on its own? And I put a 2 there. We'll talk more about that later. It's just my brain in autopilot. So, did you get in fact, I'm going to erase that too because I am. Did you get zinc and chlorine and together and then H over there? And did you get nothing? Nothing happens. So those are kind of the 4 different options that we can look at when we're mixing these 2 things together. So now what we're going to do is we're going to actually start the lab, and then I'm going to let it react, and then we're going to come back together. So to start the lab, we're going to need 1.5 to 4 grams of zinc. This is mossy zinc. So these 3 pieces right here should be enough for what we need today. So here's the first piece. It's actually enough right there. 2. We're just going to use this one. I'm going to put the other 2 back inside the container. But we are going to start with 2.5733 grams of zinc, 2.5733. Let's do that one more time. 2.5733 grams of zinc. And then we need to put 50 mils of hydrochloric acid in here. Doesn't matter as long as it's, about 50. That's why we're just going to measure it in the beaker. I know you're going to yell at me about accuracy and precision right now, which you should. But for the purposes of this experiment, we can just pour about 50 mils in here and then add our mossy zinc. So that's all I'm going to do is now I'm going to drop the mossy zinc in there, and we're going to let that react. Now, because the things that produce, we saw 2 different things. Oh, it's reacting. So now we know that number 4 is kicked out. So now it's either 1, 2, or 3. Jury's still out, but we'll come back and see this. But we have the first one here. I don't know what that would look like. The second one, we have Cl and H coming off and making a ZNH and a ZNCl. Well, what I want you to do is I want you to look up what Cl is and what H is and why we might be able to make a better prediction about what this is and what's going on here. So what I'm going to do is I'm just going to go put this inside the fume hood right now, because when you do your research, you'll figure out why. And we'll come back to look at this a little bit clearer later. Hey guys, I know that it does not seem like much time has passed for you, but we have actually had an entire day pass. And let's take a quick look at the material inside the fume hood. I've got a camera on it, and we are about to start heating that and evaporating away the material. So let's go ahead and move over to there. And notice that it's yellowish in color. That's just some impurities that are inside of the hydrochloric acid. But all of the zinc has been now eaten by the hydrochloric acid, I guess you could say. So that's heating, but there's a small issue. You know, we know something here happened, so we know it's 1, 2, or 3 that happen right now, but we also saw that gas go away and bubble away. So if it was 1, we don't see an other thing that we could say that gas is. So right now we can say either that gas is chlorine or hydrogen. And you and your group are going to be the ones that tell me which one of those two it is when you're writing up your CEJ board. You know, you're going to tell Mr. Muoka or myself that one. But, you know, part of being a good scientist is, and this year is, even if you don't get to do the labs, it's teaching you that everything is recoverable. So we need to know the mass of the material that is in the fume hood that's going to start evaporating or boiling away the liquid so that all we have left is a solid product. But we need that mass. In order to have that mass, we're going to do it like we did on some of the other ones, which is mass by subtraction. That means we need the mass of the beaker that's inside of there. Well, here's what we're going to do. Since that beaker, right now, we don't have a mass of. In fact, I don't want to get this rolling. I want to take this with me. So that beaker that was inside of there, which doesn't have a mass, that might be a little detrimental if we're trying to do separation by mass. So instead, what we're going to do is we're going to transfer it from one beaker to another. And all I'm going to do is I'm going to put this beaker in here and say that that beaker's mass is 98.7994. Now what I'm going to do is go right to here, and I'm just going to transfer the liquid from here into here by a process that we call analytical transfer. Analytical transfer means I need everything that was in here to be in there, so I'm going to give it a quick rinse 3 times with some distilled water, because I'm just going to heat that water away anyways over there. So now I can say that, you know, 99% of the material that was there is in there. So now if we have a small error, it's going to stay small, and we're still going to be able to determine what we need to determine. So let's get this back on the fume hood, in the fume hood, and heating. And I'm going to let that roll inside of the fume hood. So we're just going to take a quick break and watch that roll, but I'll speed up the video. We'll come back together after that's done. All right, everyone, we have boiled away all the water. You saw that happen right before your eyes. At the very end, you saw me swirling it around because I was trying to make sure that we could boil away all that water, and the crystals like to, or when they form, they like to trap some of the water inside of it. So I was just trying to make sure that it spreads out to the side pretty evenly. We're trying to avoid this reddish color because that means it went just a little bit too far. However, the one, when I bring the sample over to here, you're going to see that it has started to turn a little bit red, but that will not affect your final data. A little bit red is better than the deep red. Plus those impurities in there are making it turn that yellow and red color. It should be a nice white color, but impurities in the HCl that we use make it that color. So there might be another video being posted to try to help you decide between which of these two it is, whether it's the Cl or the H that is being produced as gas. Because your job is going to be to, once we mass this, to tell me, based on your values, based on your mass, and based on the work that we've been doing with mass ratios, what the X and Y values are for ZNH or ZNCl, whichever one you guys decide it is. So I'm going to go back to the fume hood. I'm going to grab that. We're going to mass it. And then I'm going to say, be ready for a CEJ. So let's get that. So just to show you, this material is now completely dried inside of there. There's no evidence of liquid. It's cool to the touch, which means that it is ready to mass. So you got the mass of the beaker beforehand, and now the mass of the beaker and the material inside of it is 104.50. We're going to call that 50. We're going to call it 5023. It keeps on flipping up and down. It might be still a little bit warm, but 104.5023. Okay. So ladies and gents, using information that you found from researching, using the data that you collected in this lab, you need to tell us which of these two lines is correct between 2 and 3, because we kind of already eliminated the other ones. And then, what is the X value, what is the Y value once you've identified the correct line? So, see you in class.